This OEM horn for the 911 doesn't work. And before I pay the Porsche tax and replace it with a new one, I thought I would open it up and see if I can make it work. I learned an awful lot with these 356 horns. These are a lot more expensive to replace than the 911 horns. These brand new are each about 100 bucks, 80 bucks each, like something like that. There's a high and a low tone. Same with 356, there's a high and a low tone. I guess the Germans want to yell at you twice. But anyways, these were incredibly complex. Let's hope that the 911 ones are a little bit more simple. If this is not fixable, it's just gonna go in the trash. We're gonna start with going direct to the battery on these. That's nothing, it's connected. So let's switch the polarity. I don't think the polarity makes a difference. I'll show you why in a minute. But this side is the low tone, it's completely dead. This side, I remember when it was in the car, was intermittent. So I get nothing on this one either. Switch the polarity. This one makes a little squeaking sound, but not much. Oh, started. So once it warms up a minute, you shouldn't have to do that, but yeah, this one sort of works, but it's intermittent. I'm gonna take them both apart and clean them and refurbish them, but at least we have something to compare it with. And we know this is the side that works better than this side. And always with anything that's this old, I'll almost always use Croil on the threads just to make sure that disassembly is easy as possible. And I am noticing a little bit of a crack here right next to the name. So these being plastic are a little bit less rebuildable than the 356 ones, but we will still attempt what is some people might think is silly, but I like to fix things. There are more important things I should be doing to this car, but today I only have a few hours and it's better to do something small than nothing at all. These guys are relatively lightweight, which is nice. All right, what looks like a giant screwdriver actually fits the slot the best, so don't want to stress out the screws if we don't have to. But these are working nice, they're not too tight. Which for something that vibrates, I would expect them to have a little more torque on them, but these are easy to break, probably M4s. Okay, this is already looking a lot like the 356 horn, you guys. Simple diaphragm with a pin that goes into a set of points. So real similar idea as the 356 horn. This one is broken up into two different coils. So the electromagnetic energy on this is going to pull down this diaphragm, and then this pin is going to break the point contact, which is probably dirty or corroded. And once it breaks the contact, it releases the electromotive force, and this thing rebounds up. And this has some spring to it because it's a metal diaphragm. So what happens is it loses that electromagnetic force and it goes up, and then it breaks contact with the points, and then it once again re-energizes it and sucks it back down. So it's just a process of electromagnetically pulling it down and then releasing the energy and letting it go. Pulling it down, release the energy, let it go. And that just vibrates it at a certain frequency. That frequency is determined by the strength of this diaphragm and also somewhat, I guess, the length of this snout. So this doesn't look too horrible inside. I think we'll be able to get this to work. These paper gaskets should be replaced. They're looking a little dingy. And the thickness of that gasket can certainly affect the clearance on the points. There is an adjuster on the back. So getting the point gap perfect so it creates a good tone is this guy right here. You can see how it adjusts the height of this contact. I'm just gonna hit this guy with a little bit of super clean because this lives under the car and it's gotten very dirty over the years. I'm just gonna rinse it with water. Looks like this has a little bit of baby shampoo left in it from when I did my PPF on the window. But that shampoo is not gonna hurt anything. We're just getting the grime off this thing. One of the things I wanted to see was this adjuster had a little bit, it just came off, but it had a little bit of sealant on there to prevent this from turning or to at least give a factory seal. This is the area where the sealant has broken off and there's just a little bit left. You can kind of see there's just a little remnants there of, looks like kind of epoxy. It's yellowed already, but that's what that was. And we're just seeing a little bit of light corrosion in some of the steel components here, but you know, not bad at all. There are some markings on it. This is 12 volts as you would expect, and 6D is most likely a date code. I know this came from my 87 car, so I don't need to look that up. So next step is to clean the points. And so I'm gonna take this arm apart so we can clean it. Now we're gonna lose the adjustment on this, but I'd rather it be cleaned and fixed once and for all. The one thing I can do is just count the threads that are exposed. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 threads exposed. And this feels like it might have some Loctite on it, but it did come loose. I'm just gonna break that free and then we'll go ahead and take this one off and see how the arm is opening up. That's a fiber washer on there for electrical reasons. I want it to be insulated. There's a spring inside here, which, you know, as springs are, it's naturally kind of a little rusty, but that's not why it's not working. We have the bolt, a zinced washer, and then looks like 2 fiber washers. One is designed to go inside this bracket, like so. So see how it insulates the arm from the bolt? And then the breaker does show a little bit of corrosion, a little bit of wear. And here's the other side. A little bit of corrosion, a little bit of wear. And then this is where the plate makes contact, and that's just got a little bit of wear to it, but it kind of rubs right off. This piece, fiberglass piece, is okay. And then just underneath those breaker points are some solder connections. There's a little PCB. So what might be smart is to just measure the resistance of these coils and make sure there's no open circuits in the board or the coil themselves. 0.2, so very low resistance. So I think the coils are good. I think the only thing to improve here is the points. These look pretty bad, so I'm starting with 400 grit. It's a little bit easier to work with on my own knee just to stabilize this guy. I'm trying to keep the sandpaper pretty flat, and then I'm rotating the part every so often just to get that crosshatch and avoid wearing it unevenly. But this is heavily pitted, so we need to go pretty far. The one difference in the 356 horn is the 356 horn uses a capacitor to try to prevent these points from wearing or arcing. This horn doesn't have that capacitor. I think that's just one of the ways that, you know, things are made more cheaply over the years. A capacitor is a good idea to protect the points. Originally, I thought in the 356 horn that capacitor was used as part of the vibration circuit, but several of you told me that it's just to protect the points, which I now agree with. But as they say, they don't make them like they used to. there are the points after 400, so I'm going to keep going to 600, probably end at 1,000. Okay, those points are super polished now. That's up to 1,000 grit paper. So hopefully good as new. Just have to reassemble now. This one goes down first and the points point up. This is the contact piece and you can flip it if you want. One side just has a little bit of marks on it, witness marks, but that's not bad. But I'm going to flip it so I have a new surface on top. That goes second. And then I actually painted the bracket because when I was polishing it, I wore through some of the zinc. So these points are gonna point down, keep everything together. So I'm gonna situate it first with this bolt. So remember, there are 3 washers here. One is to center it, and the other is to insulate it. It's nice to give you a little handle here. I decided to take everything apart again and use a little bit of blue Loctite here. So just made sure that the points are somewhat aligned. You can tweak it a little bit with your pick, but you know, they're gonna vibrate and find their own center. But those are somewhat aligned, and then the insulator is also aligned. I'm gonna loosen this just to make there a little bit more space for that spring. So I got the spring centered in there now, so now we'll come with the adjuster from the bottom. And now we're starting to get those threads coming through. This one doesn't need Loctite because we can put some epoxy here or JB Weld on the actual head of the bolt once we get it adjusted and functioning. So we're just gonna aim for those 11 exposed threads. Let's take a count where we are right now. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just gonna do one more turn. And that's approximate. But now we can see that the points have spring tension and they're able to go up and down. And with the magic of the Gasket Maker 2000, we have 2 new gaskets here. A little bit of dirt in here, we'll just wipe this off. I'm not going to make any adjustments on this pin. I'm just going to put it back together and see if we get it to work. Now, I did realize that this diaphragm has multiple holes in it, and the gasket, when positioned correctly, will expose one of those holes on one side, and then I think that just creates a little bit of a pathway for moisture and pressure to go through the gasket and come out the other side, which would be on a different, you know, like on this side, you'd orient that slot over here. That's the way it was when I took it apart. You don't want to align the gaskets like this so that there's a direct hole. That's not how it was. It was positioned so that this slot was like 90 degrees out of this one. And there's a little bit of an impression where that slot was on the previous assembly, so I'm going to put it right back the way it was. And then this rectangle has to go directly over those 2 guys. Yeah, I think I'm happy with that. Now this horn is not centered, so the orientation of this does matter. I'm gonna have to go back and look at the video and see which way it actually goes. But for now, I'm gonna put this tab together with the terminals and just hope for the best. I'm not going extremely tight on the screws. We're just going to assemble. First test, I am hearing a little click, but I'm not getting a tone. And like I said, polarity I don't think matters because this thing just vibrates open and closed. So now we will, as it's connected, cycle this half turn that way, and we'll do half turn this way. And it's working, scared me. So it seems to be getting louder as you turn it. So I think you want to set it for the loudest setting, but that seems really loud. I'm going to get my headphones. I think that's it, but I'm going to let it cool down. This is physically getting warm. So I don't want to damage it, but it is working. And this is the side that wasn't working at all. So it is very sensitive to this screw position. About a 1/16 of a turn can make a difference with it turning on or not. And I think I've got it to the loudest point and the point in which it'll turn on and off. And it's very loud. So I'm going to do the same exact procedure on this side, which is the shorter horn, which I think, let's see, it says the shorter horn is going to be the higher pitched one. I think this one said low on it. So I will be right back after I do all the point repair here, and then we'll get that going too. $534. 630. I'm mixing up a little bit of JB Weld. And that's going to go over the adjustment screw just to make sure that it stays put. Got lucky again with these horns. No need to buy new ones. These should last another 40 years or so. I can't think of any reason why they won't. The points are nice and polished. I think these are going to be a big improvement over the auto parts store horn that's in the car now. I wanted something for the rally that would just basically beep, beep, say hello. These are the real deal. These are much louder and better. So I guess the lesson here is to always get something done in your car, and also don't forget to check your points every 3,000 miles on your horns.